this is going to be a very irresponsible talk. Some of the things I'm going to do today are irresponsible. Don't go back to work and say Kelsey said, okay? It's going to be irresponsible, but we're going to have fun. We're going to push the boundaries of a few things. So if you see something odd, straighten back up, smile, okay? That's what we're doing today, all right? Are we cool with that? Maybe I go back to the bullet points. I have some PowerPoint. Do we want PowerPoint? Someone's like, hell yeah! Bullet points! No. So today we're going to talk about two of my favorite communities, Kubernetes and this whole HashiCorp community, the whole HashiStack thing. I use a lot of these tools, sometimes together, sometimes in some weird, unapproved ways. It's my computer, though. I do whatever I want. But today, we're going to make a new term. You guys ready? The new term is called HashiNeties. Now, you can't buy it. I will totally take your money. But this is not a new HashiCorp product, so do not look at the product page. There will be no press release. Okay? So HashiNeties. Does this sound silly? What is this HashiNeties business? Well, it starts off pretty same. Kubernetes, or my first experience with Kubernetes was, it felt like this cloud operating system. If you've used Terraform, you feel that Terraform abstracts away all the cloud providers, and you express yourself in Terraform, and it makes things happen. Kubernetes is like that for me, but at a much higher level. If my app needs a load balancer, Kubernetes hides the whole implementation detail and reconciles it and keeps it in place actively. I can't remember the last time I actually used the native tools to spin up infrastructure at all, because I usually start with Kubernetes. But Kubernetes doesn't solve all problems. What happens when you have multiple Kubernetes clusters? Anyone ever try to do service discovery across 2 or 3 Kubernetes clusters? You can't. It's not designed for that. It's designed for inter-cluster service discovery, and it does a fantastic job. But if you add something like Consul, you can configure it in a way, Consul works natively, to kind of bridge that world. And I'm not talking about the IPs of each containers. If you try to bridge the IPs of your containers, you're going to run out of IP space. And it's going to be embarrassing as you attempt to re-IP production. It doesn't work out well. I've tried it before. Then secrets. Kubernetes has a very basic secrets implementation. It's great for bootstrapping things. We use it to bootstrap Kubernetes itself. We've added features around encryption at rest. We added features around limiting what nodes can see. But it doesn't do everything. And for a lot of people in the Kubernetes world, they're asking, why is all of this attention on Vault? Why did Vault on Kubernetes make it to the front page of Hacker News? We already have secrets. Thou shalt not bring in another secret implementation. It gets real tribal. Anyone have any product tattoos? Hey, that was a thing in the 90s. You would meet people with like free BSD tattoos. You're like, people are gonna not use that all the time. Like, you don't know, man. It's like, that ain't coming off. Shout out to all the Solaris tattoos in the audience. Yeah, there's some Solaris tattoos. All the people with long sleeve, it's hot as hell. But you got a long sleeve shirt on because of Solaris. This is a great stack. This is the HashiNeties. But the other day I was experimenting. If you're a manager in the office, an audience, if your people aren't experimenting, it's probably your fault. You don't have to clap if you report to your manager. Just kind of do this for me. Thank you. Let them play a little. So I was experimenting. I was like, hey, I have all this compute. And sometimes I write these little statically linked binaries, and having to put it in a container, which is the price of admission for Kubernetes, even I get pissed off sometimes. And I can do it in a single step, but sometimes I want to avoid it. And I cheat. No one's looking. I reach for Nomad. So in my world, I have a little bit of this going on. People's like, dude, is that 2 schedulers? I'm like, yeah. I got 2. And people say, you're crazy. Does this seem pretty odd? But you do it all the time. Most people have some hypervisor underneath. You use some cloud provider, and when you click to create that VM or make an API call or use Terraform, there's a scheduler placing your VM somewhere in the infrastructure. And you're totally okay with this. And then you do what? You install yet another one on top and do the same thing, but you think you're sane. So in this world, I want people to say, hey, these are just interfaces to give us compute in the way we want to consume. Some schedulers give us a raw machine that we want to SSH into. Some of these schedulers are like PaaSes that just take our app and just find the right place to run it, and we don't care about the machine abstraction. But there are some cases, and I think CircleCI recently put out a really good blog post about why they use both. I'm not telling you to use both. I'm just saying be irresponsible sometimes, OK? You're an adult. You get to do that. So I want to take us through this, all right? We ready for some terminal? They told me it was OK to use the command line. All you PowerPoint people, I'll get back to you with some slides. OK, so we're going to start with this cluster. Look at the name of it. Hashtag HashiNeties. So we have these 7 nodes in this cluster, and I have a few things running there. OK, so in this cluster, I have Consul and Vault. Now, these are 2 stateful services. And most people say you shouldn't run stateful stuff in containers. I'm like, but why? Containers themselves aren't the problem for stateful. It's usually the underlying platform may not be able to pair up your storage. So how does Kubernetes make that any different? I mean, some databases you will probably lose your data, OK? So don't go and run everything in there, but some things do make it easier, Consul being one of them. The fact that Consul does replication and has the ability to heal under certain conditions, it does its part to make Kubernetes life much easier. So if I come here and I say kubectl get pods, we'll see if Wi-Fi actually works. You guys should clap because Wi-Fi works. The rules are the more you clap, the more favor I get from the demo gods, OK? Because they want to see how this goes, OK? So we have this 3-node Consul cluster. And like one does, you have to run the release that they did yesterday. OK, that's what we got going down. So that means if anything breaks, it's not my fault. If you work on Consul, I will look at you. That means I need help. Don't leave me here stranded. All right, so we have this 3-node Consul thing. But the other thing that we get is this thing called a persistent volume claim. So this is where all I do in my manifest is say, hey, I need storage of this kind. Based on where I'm running, on-prem, it could be iSCSI or NFS. Amazon will be there, Elastic Block, and Google Cloud will be there, persistent disk. Don't need to think about that. Kubernetes' job is to actually provision the storage, give it an ID, and make sure that the storage can be mounted in the zone where the workload needs to live. And give me stable names to make sure that they're always paired back together. So all the stuff that you used to do around orchestrating stateful things, Kubernetes will meet you probably more than halfway. So given that, I can actually rely on Kubernetes to do the right thing. If these apps die, they will ensure they're paired with the right storage even if they move to a different machine. Great. Again, I'm going to skip one of the use cases, but if I had a VM onto the side, you can actually delegate DNS to Consul for the Consul domains. So what that looks like is we have this thing called kubedns. And what I could do to kubedns and say, hey, Kubernetes is responsible for all the service discovery that happens in the cluster. But if I'm running Consul side by side, I can also do something like this with this config and tell kubedns that if anyone looks up .consul, delegate that to the Consul service running in cluster. So that allows me to actually go over a broader landscape than what I currently do on Kubernetes. Sweet. The next thing is Vault. All my Kubernetes people are like, why are you using Vault? what's the use case? The first thing that got me hooked on Vault was the dynamic provisioning of secrets. But I want people to be clear on what we're doing with Vault. It took me a long time to understand, why do we have all of these systems? Why do we even need Vault? You ever thought about that? Why does Vault even exist? And some people say, you just need it. We got all these secrets. It's better than putting it on disk. And the more you think about it, and I talk to colleagues, and they say, you know what? If you think about it, Vault is an identity translator. You have something that you know and trust, a TLS certificate, a JOT token. And the problem is your database, or Redis, or some other system, has no idea how to use that identity or trust the thing that gave it to you. But it does understand things like usernames and passwords. So you trade Vault for one of those things that it trusts, and you go back to it. So you could imagine a world if everything understood X509 certificates. But that's not where we are. So Vault is required. So here's the magic sauce. If you're a DBA, I've seen DBAs do this before. It's like, hey, I need a username and password for my app. They're like, I got you covered. Then they do this. I'm like, well, what are you doing? They're like, hold on, I got you covered. And they keep on clicking. I was like, dude, your mouse battery is running low. Probably from all of that clicking. Like, there's better ways of doing this. And they're like, no, no. And it's like, I have the GUI. So this is a modern thing for some people. You can click into here. And he's like, how many usernames do you need? I need 3. They're like, no problem. Got you covered. Have you ever seen their database? Anyone know what a pivot table is? Yeah, in their databases, you can build pivot tables. It's like a real programming language. So here we have users, and then what you see people do is click in there and say, what tables do you want to access? I'm like, oh, stop. Stop. You're supposed to know this. Just give me credentials. So the magic I show my friends is I slow all the way down. So I'm going to show you magic. And it's like, OK, I'm going to bring in Vault. So Vault's installed. I unseal it, too. Are you guys like me? Do you do this? How many people just make noise if this is you? Just be honest, though. Don't be trying to be fake. Be real honest. Is that you? Hell yeah. Defeat the whole security mechanism. You have the airport's like, dude, I have all the keys on this laptop. It's like, you are just not doing this correctly. OK, so we're all on the same page, at least. So Vault is ready, so let's do a Vault status here. All right. Great, we're unsealed. So this is what I do. So I have all these configs in place that, hey, Vault's going to dynamically create secrets for you. But yesterday they announced the ability to use service accounts in Kubernetes to skip one of these bootstrapping steps, right? It's like, how do you automate giving out secrets end to end? It's super hard if it's not built into the platform. So in Kubernetes, we have what we call service accounts. So service accounts are a way for us to give identity to these tokens and give them a set of permissions. We have rich RBAC inside of Kubernetes. So if you have this, you can actually assign, and listen to me here, do not give Vault the default service account. Do not give Vault the admin service account. Give it a service account that can do nothing but log into Vault. I don't want you to be on the news. This is serious. All right, back to being irresponsible. So you got service accounts. And what you do in Kubernetes is you tell your workloads what service accounts they should use. So one of the workloads I have is this very simple job. So this job is a lot of config here, skip most of it, but I am doing things very secure. That's one thing I won't compromise on. So I'm using TLS end-to-end. If you look here, I'm saying I want this app to use this particular service account. The nice thing is this is built into Kubernetes. Kubernetes will inject this service account at runtime. Vault only has to trust Kubernetes and the holder of that service account to identify who you are, okay? And in Vault, you attach all of these to policies and so forth. So here's the trick. So we run this now, okay? So kubectl, get pods. We have our control plane. And now I'm going to run this thing and observe what happens. It's going to go fast, though. So here, we're going to run it. kubectl, get pods. It's a job. And it goes so fast that it finished. All right, so we're going to do it in slow-mo now. We're going to type a little slower, as if it's going to change anything, but it won't. So we'll just look at the exited worker. And they're like, what did you do? You just ran a job. What did you do? So we do kubectl logs. And then what we want to do is see what actually happened here. So this particular app grabs its service account, reads it, presents it to Vault at login. Vault trades it for a real token that it can use. And it goes out and says, hey, give me database credentials. And you see here that it got this username. They're like, dude, your spreadsheet's going to get big if you're doing that. And I was like, but there's a better way. So we come over here, and we look. And they're like, where's the user? I was like, let's do it again. So I slow it down. So one more time. So we're going to delete the work. So it's kubectl delete jobs worker. All right. Then we're going to run it again really fast. And then we're going to switch really quick. You saw that tab, the keyboard shortcuts? Whew. The username's there. That was my fellow Kubernetes user. He was like, sweet! I'm deleting all my spreadsheets. So now it's there. And they're like, all right, whose job is it to clean that up? So you look at it and you scratch your head. We could put a search engine in the spreadsheets. There's APIs for spreadsheets these days. And you look at the workload, and it's not there anymore. It stopped running. So what we really want this to do is, let's see, tick tock tick. Their minds are blown. Who took it away? Magic. You wait 3 days before you tell them it's Vault. So Vault and Kubernetes, to me, make a really good pairing because I think this kind of capability really matches this idea of these dynamic workloads. So we have this nice stack, Consul, Vault, what else? And I'm saying, well, sometimes I want to run things in Nomad. It's like, man, managing two schedulers. These big tools, you need to think about them. How do you deploy them? You need Terraform, you need all of these things. I'm like, I can just use the Kubernetes API. I can represent it. So the beta came out yesterday. I was like, yeah, that's like production ready, right? Like beta is just like less support, but it's still production ready. That's the way I think about it. So I was like, hey, I'm going to run it in my cluster. And how many people think it's hard to run two schedulers or even one scheduler by itself? Oh, you guys are all badasses. You're all lying. Pretty badass. OK. So one way I thought about experimenting with this is like, what if you could just say, give me a Nomad cluster? All right, let's just try it. Let's see. So if someone calls me, just ignore it. All right. So we're going to see if we make this work. I see Wi-Fi is not on my phone. So this is when you do like LTE for the win. I don't know if this is smart. Let's just go with it. Talk to, what is this thing called again? Anyone remind me of the name? You guys don't know? HashiNeties. I worked really hard on that name, too. Like, talk to HashiNeties.
Sure, getting the test version of HashiNeties.
Hello, Kelsey.
Hello.
I see you're tempting the demo gods again. Over conference Wi-Fi. That's extra bold. How can I be of service?
All right, so we need Nomad. We're just going to watch and see what this thing can do. Hey, OK, bring my screen. I just have a simple question. Deploy Nomad.
Creating a 3-node Nomad cluster.
Awesome.
Yo dog, I heard you like schedulers. So I deployed Nomad using Kubernetes. So you can have a scheduler in your scheduler.
Irresponsible. So we're going to allow this to bootstrap. And what's happening underneath the covers is we're using the same mechanism of this is the stateful application. it's also clustered. We need to do them in a specific order. We need to mint the storage and make sure the storage is ready, mount it to the machine, configure console to have console join the larger cluster so we can do the service discovery to fully bootstrap this thing. There's an entire config behind this. So as we're bringing this up, we want to see the cluster form. And then once the cluster forms, we're going to see if that fancy dashboard is any good. Anyone play with the dashboard yet? You haven't played with the dashboard? I show my wife these things. She's like, why are you showing me? What am I supposed to get out of this? It's like, it's a, never mind. All right, so we have 3 nodes here. So is this actually a working cluster? Truth be told, this didn't work this morning, OK? So I'm a little nervous right now. So one thing we can do is I'm going to source this Nomad environment variable, because we're doing this over the web. And we're going to say Nomad server, like I know what I'm doing. You got to do it with confidence, man. You just type harder. Oh, we have a leader. OK, well, let's see if this dashboard is available. Do you know how long it took me to figure out how to do client TLS auth with a browser? Anyone ever got that to work? Well, it doesn't work easy. But I got it to work, and I'm very proud of myself. So what we're going to do now is try to hit that fancy dashboard of theirs. Let's see. Here, so we grab this, and it's on 464. If you don't think I'm using TLS mutual auth, go ahead and try it, and I will laugh at you on the inside. So click this. And, all right, ooh, we got some servers. Now you can drill around here, and this is pretty nice. I'm like, okay, GUIs are good. Now you ask yourself, where did the workers go? If you were thinking that I would deploy the workers inside the same cluster and run them on Docker on top, that's ridiculous. Okay? I'm irresponsible. That's ridiculous. You should run them in their own node pool, right? In the cloud or even in your own environments, you usually have the ability to have some elastic pools. Use them to your advantage. We can say if we have a certain set of jobs that are optimized for what Nomad wants to do, just create another node pool. So we're going to come over here like a badass with the mouse, and we're going to click on what you already know, instance groups. Click. Grab one of these, and we'll add a few. How many should we do? Throw out a number. 1,000 divided by 100, cut in half, that's 5. All right. I mean, you're calling the shots. All right, so we're going to spin up these nodes. And I'm not trying to promote a cloud provider right now. This is my on-prem, OK? I work at Google. This is just my normal infrastructure. All right? Legit. Did you see how fast they came up? Woo! Marketing, I've done my part. All right, so we have nodes. Now, the nodes are doing a bunch of stuff, right? So this is what happens when a speaker's trying to buy time for things to bootstrap in the background. This is what we do. We wave our hands, and then we may do this and say, did you see that? Knowing you didn't see anything. But we have these 5 nodes. OK, now the goal with these 5 nodes, if it works, that they will show up here at some point. I'm going to hit this hard refresh. Huh. So you ask yourself, like, did you push it too far? Because there's a limit to this thing. And did we go too far? We got 5 nodes. I'm feeling good about myself. So you click around. The GUI is actually really nice, by the way. Like, maybe you shouldn't see some of my secrets here. I'm a little worried about this one. But overall, it's good. This is why I turned on the TLS off, because I didn't want you guys to do weird things to my thing. So all the clients are now fully bootstrapped. Join the cluster. I can even do cross-cluster service discovery. They both have Vault integration. So what next? Run some jobs. So we'll go to jobs. So the jobs integration is actually super nice. So let's see what we can do with that. Maybe we can talk to Nomad now. We talk to Kubernetes. See if we can talk to Nomad. Run the, I don't even know the name of the job. Run the ping Nomad job.
Here are some results from the web.
Run the ping Nomad job.
Here are the top search results.
It's trolling me. All right. Run the ping Nomad job.
These are the top results.
I'm not abandoning ship. I'm going to go through this one. Let's call it again. Talk to HashiNeties.
All right, let's get the test version of HashiNeties.
Hello, Kelsey.
Run the ping Nomad job.
How many?
12.
Creating 12 ping tasks in the Nomad cluster.
Thank you.
When Seth said pick a scheduler, I'm not sure this is what he had in mind, but I gotta admit, this is extra dope.
Running.